analysis, an analytical technique based on the measurement of mass. So this is one particular way where we can figure out how much of an element is there in a particular unknown compound. Let's look at the steps for it. It says, 1, dissolve a sample of an unknown compound in water. All right, mix with another substance to form a precipitate. So if we're forming a precipitate with this is a double replacement reaction. Filter, wash, dry, and weigh the precipitate. Then, knowing the mass and formula of the precipitate, we're going to do some calculations and figure out how much of the that particular component is in the original sample, and then we can figure out the percent composition. I think it's a little bit easier if we look at a picture of it here. All right, so in step 1, we have an unknown solution that has lead in it. I'm sorry, an unknown solid that has lead in it. Right? Could be lead nitrate, could be lead chlorate, something that is soluble in water. All right, so we dissolve it in water, and now we're adding a solution containing the sulfate ions. Why? Because we know lead sulfate is insoluble. So when we add those sulfate ions to the lead solution, we're going to get lead sulfate precipitated up. All the lead that we started with in step 1 is now part of the precipitate at the bottom of step 3 here. All right, it's all in the form of lead sulfate. What I could do now is go filter it and weigh how much lead sulfate I have. I can use the formula to figure out the percent composition of lead in lead sulfate to figure out how much lead I have in this precipitate. And like I said, the amount of lead in the precipitate is the same as the amount of lead that we had in the original salt. That we know there's lead in there. We don't know what percent or how much is in there. This is a way that we can go back and figure out, well, what percent of our original sample was lead. All right, so let's take a look at an example here. 9510 gram sample of an ionic compound containing iodide ions and an unknown metal is dissolved in water. Excess silver nitrate is added to the solution. A precipitate is formed, filtered, washed, and dried. The mass of the filter paper before was that, and the mass after was that. What is the percent by mass of iodine in the original compound? All right, it seems overwhelming, but let's break it down step by step. If we ever saw this on an AP test or any kind of test, it would be broken up into many steps. All right, the first step is, what is the precipitate that is being formed? Now, since we know a little bit about chemistry, it says it's all about this iodide ions. All right, so it's all about I minus. So something has to react with this to form a precipitate. The only other thing they mentioned was silver nitrate. Now, the bell should be going off because silver nitrate is AgNO3. That's the Ag plus ion and the NO3 minus ion. What do we know about nitrates? All nitrates are soluble. They'll never be part of the precipitate. So what am I left with? What's my only option? AgI, silver iodide, is my precipitate. All right. Next up, we have, what do we do with this? Well, let's figure out how much of our precipitate was actually formed. All right. The way that we do that is we look at our filter paper. We see that the mass of the filter paper plus our precipitate is 4.2204. So I'm going to subtract from that the mass of the empty filter paper. So I get 1.2420 grams of AgI. That is how much iodide reacted with my silver, forming that silver iodide. All right. Well, we know that the formula is AgI. So I can calculate the percent of iodine in AgI. I can use my periodic table. I look up silver, 107.9. I look up iodine, 126.9. I could add these together. get 234.8. To calculate the percent I can take my part, 126.9, over the total, 234.8. When I do that, 126.9 divided by 234.8, I get 0.5405. So that's 54.05%. All right. So that tells me that no matter what sample I have, 54% of silver iodide is iodide. So all I have to do is find out what 54% of 1.2420 grams is. So I'm going to multiply 54.05% times my 1.2420. And that's going to give me my mass of iodide in my silver iodide. So that times 1.2. 1.242. So I get 0.6713 grams of iodine. I or I minus, either one. All right, I'm getting closer. If that's the amount of iodide in my silver iodide, that is also the amount of iodide that we started with. Right? Going back to our example here, instead of lead, we're kind of focused on our iodide. Instead of sulfate, we're adding silver ions. So we're getting our AgI out of this, silver iodide. So whatever iodide I get here, that all of this came from the iodide that was in my original unknown sample. So going back to this was my original mass of the sample, 0.9510. So to figure out my percent iodine in the original, I'm going to take my 6713 grams, the part that's iodide, over the total, by 0.9510 grams. That divided by 0.9510. So I'm going to get 70.58% iodine. All right, that's a long problem. It would never be given to you just as like, here's the final answer. This will be broken down into many steps. What's the precipitate? AgI. What's the mass of the precipitate? What's the percent iodine? What's the mass of iodine in the precipitate? All right, and it'll work your way through there. But it's a way that we can use gravimetric analysis, that's the term for it, of how to get through and calculate this unknown value, the 70.5. And that is gravimetric analysis.